on, I'm in R2 still. Okay, I'm working out of R2, R.2. Translate this into an equation. Take the words and translate it into an equation. So do we all know what a sphere looks like? It's three-dimensional. Something like that. There's a sphere. It's not a very good sphere.
No, it looks great.
You like that? I should probably smash this down a little bit more, but that's okay. You have a center of the sphere, and you have a radius, which would come from the center out to the edge, right? Like this. Call that R. The volume of a sphere is 4/3 times pi times the cube of its radius. So write that out. What do we got? Kayla? What? No, I was going to see if you would help me with this. So can you write an equation that turns all those words into like something equals something? So what do you want to call volume, Kayla? You want to call it X? You sure? How about, since it's volume, yeah, why don't we go with V? Right? Volume of the sphere is equal to, so is, right? Doesn't the is mean equal? Is 4/3 is just a fraction times what? Pi, that's just a number. It's an irrational number, right? Times the cube of its radius, r cubed. This would be the volume formula for a sphere. Does everyone know the area of a circle? What's the area of a circle? If someone gives you a circle, now we're in two-dimensional space. Flat sheet of paper, this is R, then the area would be what? Pi r squared. You may have heard that before. I hope you have. The area of a circle is pi r squared. The volume of a cube, which means how much it can hold. Like if you're able to like drill a hole and fill this thing with water, how much could it hold? It could hold 4/3 times pi times the radius cubed. That's how much you could put in there. Anybody know what the surface area is? No? Not as well known. It's not as well known as these two. It's 4 pi r squared. 4 pi r squared, I believe. I'm sorry? In Calculus 2, because I know a lot of you are taking Calculus 2, you can actually prove, you can actually show where this formula comes from. You can create the formula yourself, which is a pretty interesting problem in Calculus 2. All right, next. We're going to move into the next section, which is R4. I'm still reviewing, right? We're not starting anything new today. I think that from the look of what you asked me on those 20 questions, I think that your factoring is probably okay. Maybe we can practice a long division problem, because maybe it's been a while since you've done long division. How about this? I'm doing number 90. I'm in R4 still, or just doing this problem in R4. Number 90. Let's take 3x cubed minus x squared plus x minus 2 and divide by this. Divide it by x plus 2. I think I want to change the problem. That seems to me a little bit boring, but we'll do it. We'll do it. All right, so I'm going to pass this around. Please just find your name, initial under Wednesday, just initial right there, and then pass it around. Make sure everyone signs this. Remember, if you see green here, it's because you did not complete that online quiz. You need to do that. Okay? So can you all do long division? Do you know how to do long division? Do you all remember this? I'll refresh your memory. Okay. So it goes like this. They call it long division because you have to do it like the old school division way, right? Liz, would you like to do it? Oh, no, I'm not asking you to come up here. You want to help guide us to this? Okay, so x plus 2 comes on the outside.
3x cubed minus x squared plus x minus 2.
Goes here, like that. And then, can you help me explain what I need to do now?
You have to find how x goes into 3x cubed.
So you're trying to figure out how x can turn into this?
Yeah.
Okay. Yeah, what do I multiply x by to get 3x cubed?
3x squared.
3x squared. Right, so it's an okay, we're good, Liz. But you got to get off your phone. Right, everyone, what's the penalty for being on your phone during class? 10 points. Liz, you strike me as an A student. And it would suck to know you can't get an A on that first test just because you're on your phone. You know what I'm saying? So I don't want to make an example out of anyone. That's the one warning, right? Everyone signed the syllabus thing that says, I understand the requirements of the course. So I assume that if you understand that, then you understand that being on your phone, you're willing to take the 10-point penalty. It's that good of a conversation you're in, all right? It's worth it. All right, so thank you, Liz. That is, what do I multiply x by to get this? And you said 3x squared. And some people get real anal about where they put it. Some people like to put it like above the x squared column, so to speak, but it really doesn't matter where you put it. Now what? Let me see. I think you've got it, Liz. So I'm going to call on someone else, like Jordan. Because Jordan had something come up today, so he was a little late, so we're going to ask him, get him up to speed. Any idea what you do now?
Well, that was the part I knew right there.
That's the part you knew, okay. So what do you do? Again, we can go back to an example, something like, what if you were taking 15 and dividing it by 2? Back in grade school, you'd put 15 here, you'd put 2 out here, and you would say, what do I multiply 2 by to get 15? You'd say, what, about 7? And then what do you do from this step? What do you put under this? Where's the 14 coming from? 7 times 2, right? Gives you the 14. It's exactly what you do here. 3x squared times this. So it's this times this. And if you need to do it on the side, you can, but I would hope that you could do it mentally. You're doing 3x squared times the x plus 2. And you're distributing the 3x squared to each one. Another way is just say, what's 3x squared times x? 3x squared times x. 3x cubed. And then what's 3x squared times positive 2? Positive 6x squared. Okay, understand?
Oh, I was going to say, don't you have to change the sign?
Yeah, so coming back here, we put the 14 here, didn't we? 7 times 2 is 14. And then what did we do? We subtracted, right? So we changed the sign from the 14 to negative 14. We do the exact same thing here. We come in and we say, I'm going to take this and I'm going to change the signs. So since I'm changing the signs, I'm kind of get a little bit like exaggerated here so that everyone sees I did change the signs. And then we add straight down. So these go away. They should always go away, or else you messed something up in this. And then here, negative 7x squared. Because negative, added together, you're still negative. Plus, you just bring these down, plus x minus 2. And then, repeat the process.
How come we don't ever do anything with the 2?
Where?
Like the x plus 2. Divide that in.
What do you mean? Like the plus 2, why are you just looking at the x? Because the plus 2 is going to come along for the ride. When you do this times this, right, that plus 2 is going to have an impact on this next line, isn't it? So you're always going to be looking at the highest power of x as the one that you're trying to transform into that first piece. Whatever else is out there is just going to, like I said, join with you when you multiply through. So now I've got to take x and I've got to turn it into what this time? This now, negative 7x squared. So what do I need to multiply it by? Negative 7x. And then you repeat. Okay? Repeat through. So negative 7x times x is negative 7x squared. And then negative 7x times positive 2 minus 14x. Come through and change the signs. I'm out of room. But what is that next line down there? 2x, oh wait, yeah, these are gone. 15x minus 2. I guess I'll put it down here. 15x, I know you can't see that, and I can't even write like that. 15x minus 2. And then we go again, don't we? What do you multiply x by to get 15x? 15, so I put 15 here. All right, multiply that through. So I'm just going to continue that last line up here. Here's what we've got on that last line. When we multiply the 15 through to the x and to the 2, we get 15x, and then what's the next number underneath? 30, right? That's 30. Change the signs. Question? What? No, it's okay. Okay, so I figured that from this point, I had 15, I know you can't see it, 15x minus 2. I have to turn x into 15x, so I multiply by a 15. That 15 now hits the x, becomes 15x. 15 hits the 2, becomes 30. And then I'm going to change my signs. This is going to become a minus, and then add down, and I get negative 32. When do I stop? That'll be a remainder. So I'm going to stop when the power on x here exceeds the power on x here. So like here, look at the power on x down here was 1. The power on x here was 1. So I had to keep going. But now the power on x here is 1. I don't even have an x. So I can't turn x into negative 32, so I stop. But this is my remainder. So how do we write remainder? Yeah, that's the way the book does it at this point, but that's not the way we like to write it in grown-up math. In grown-up math, what we do is we say, this is our answer, but not quite. We're off a little bit, right? We're off by this much. We're off by our remainder, negative 32, over the divisor, which was x plus 2. Now let me try and explain that in another problem. When we did 15 divided by 2, right? You do this. 7, 14. What was your remainder here? 1. So do you remember in grade school, at some point you did R1, right? And then later you put the 1 over the half, like the 1 over this. So we say 7.5. Yeah, you remember seeing that? But 7.5 actually means 7 plus a half. That's what that means. This is called a mixed number. Right? This is called a mixed number. Mixed numbers are terrible. Okay? Just purge these from your system. For those of you who are going on, which is most of you, to do more math, mixed numbers are like when you see someone still using that symbol for division, you kind of look at them and go, well, you got a ways to go still, right? I mean, they've got, right? They're like times, and they're using that. You're like, no, that's going to be x later. Don't use that, right? So it's kind of like when you see mixed numbers, you're still working in a lower level. You need to be, if you're going to work with a fraction, you convert that into 15 halves. It's called an improper fraction, and that's the one you want to use. Again, bad naming on it, right? Improper makes you think that I shouldn't be doing that, but improper is the one that we like. Okay, that's long division. The other problems out of that section are all like multiplying things out, collecting like terms, x cubed plus 3x squared, and you add things together. I think y'all can handle that from the looks of the problems you asked me about. Okay, what about what's next? Where's that sign-in sheet? Did it get around? Who needs it? Anyone? Over here? Okay. Here. No problem. What's the next section? R7? Rational expressions. Now this can be a bit of work. Yeah. Okay, so you got it? Let me take a look at some of the stuff on this. R7, 14.
14's not bad.
Yeah, 14's not bad. Let's do 15 just to make sure we're all on the same page here. By the way, your homework for tonight is to attempt, or for the weekend, is to attempt all of the homework out of all of the review sections on this calendar. So I may not get through all of this, but it's review topics. See how you do with it, and hopefully when we meet again next week, you'll have some questions. I unfortunately will not be able to invest an hour in the class to answer questions over review stuff. I don't mind doing maybe 2 or 3 problems at the beginning of class. I encourage you to come see me in my office if you need help on something. Right? I'm in my office before class. Right? And then on Tuesday, Thursday, I'm there from 9 a.m. till 1 p.m. and then 3 p.m. to 4 p.m. So I'm around. If we need to make an appointment, we can do that also. But come in prepared. When do the in-class quizzes start? Probably next week. All right, I'll probably start with the quizzes, and I'll always quiz you over something that you were supposed to have done. So if I come in on, Monday? If I come in on Monday and I give you a 2-question quiz over some problems out of the homework, that to me would be fair, because you've had an opportunity to ask questions. You could have come to my office, you could have got tutoring, but I'm assuming you're coming to class and you've got this stuff pretty much understood. I won't go pick the hardest ones, I just want to know generally, are you okay? I never changed the schedule on this thing. All right, so what am I doing? Number 15, x squared plus 5x minus 14. Over 2 minus x. This is number 15 in R7. The instructions on this problem are to reduce each rational expression into lowest terms. So they want you to clean that up if possible, make it look a lot better than it does. So the numerator is, see, who have I not? I feel like I haven't picked on enough people today. But when I look around, I feel like I've picked on everyone also, so I'm not sure. Who hasn't been picked on today? Okay. Do you have any idea? Thank you for volunteering. No? When you see quadratics, what do you want to do? What do you want to see when you see quadratics? If there was an equals, yes. Factoring, right? Okay, this is the whole section is really an exercise in factoring. Can you factor? If you can't factor, this section is going to really, really suck. All right, so I'm going to factor the top. How do I factor the top? I probably use that method over here, negative 14 and 5. I probably play that game, and I try and break this down. That is a prerequisite topic for this class. I expect that you could factor that. So I'm not going to show you that over and over and over. So let's assume you can get to this next step. The top factors to be, anybody? There we go. On the bottom, 2 minus x. We're not done? Flip it. Okay, yes, you're on your way. Negative 1. Okay, so keep this in mind. You're trying, if possible, to get things to cancel, right? These two look like they really want to cancel, right? They're almost the same. This one is positive x, this one is negative x, this one is negative 2, this one is positive 2. So they are off by a sign. Exactly a sign, right? Everything that's positive here is negative here. Everything that's negative here is positive here. So what we can do is we can just factor out a negative 1. Now, we could factor the negative 1 out of the top or the bottom. I'm going to do the bottom. So I pull a negative 1 out. And what effect does it have on this? Switches the signs. So I have not changed the problem. I've pulled a negative 1 out, just to be clever. And now these two are going to cancel. Now, that's a standard trick. I'm just rewriting this. I'm flipping them. You don't need to do that. I'm just trying to illustrate again that these two are the same thing now. And so they'll cancel out. But I still have a negative on the bottom, don't I? So I should probably write my answer like this. It makes no sense to put that over negative 1. So how about just put the negative on top? Isn't that the same thing?
Yes, sir.
Okay. That's our answer. Now that was an easy one because that was in the beginning. Let's look at some stuff that's a little harder. Yeah, they just get tedious. Yeah, let's just throw you into the fire here. These just look worse than they are. Again, the instructions here are to simplify this. I'm doing number 32. I'll get out of the way in just a second. Sorry? Simplify this. Just make it look nicer. Just make it look nicer. Now, I'll point out something in the book. I don't know if you read this problem out of the book, you'll notice that the lengths of these bars in the book, all the lengths are exactly the same. But the bar in the middle is bolded. It's a little darker than these two. And that's very important because when you deal with what are called complex fractions, you have to know where the main division is taking place. Here's an illustration of what I'm saying. What is that? What is that? You don't know what this is, okay? Because I wrote it in a poor manner. This is bad math penmanship, okay? Because one person could read it and say, I take 12 divided by 3, which is 4, right? And then 4 divided by 4, which would be 1. Another person could read it, no. He means take 12 and divide it by 3/4. That would be a different answer. Understand? So what I need to do is somehow designate where my division bar is. So I would do something like this. I would extend this one out. And now what that means is you do this first, then this. And that's the same thing in the book. Pay attention to that. They have the same length bars, but the one that is the main division is occurring in bold. All right? So when you see this, let's see, I think I've got, who doesn't have their name thing? I see some, you have your name thing? Do you have it from last class? Okay, so you'll make one today? All right, good. You can't get away from this by just not making one and putting it on the desk. Here.
Yeah, I tried that one yesterday.
You tried that? Yeah, it's not going to work. You were here yesterday? We weren't here yesterday.
Yep, I hate both of them.
All right, so factoring, this is factoring heaven. If you love factoring, this is factoring heaven right here. If you like trinomial factoring. So let's see. Here's my main division bar. Let's factor this top one. X plus 1, X plus 6. And the next one below that, X plus 3, X minus 2. Next one, plus 6 minus 1. And finally, X plus 3, X plus 2. There we go. I wasn't really paying attention. Does everyone agree? I trust you, but yes? All right. So when you have a fraction and you divide it by another fraction, that's equivalent to multiplication, isn't it? Multiplication of the reciprocal. So what I'm going to do here is I'm going to leave this one alone. I'm going to bring this one up here next to it, but I have to flip it over. And to save some time and space and not getting a cramp in my hand, I'm just going to continue from here and just slap it in here. So the bottom becomes the top. And then the top became the bottom. And if there's any justice in the world, something's going to cancel. X plus 6 and X plus 3. And that's it, right? Now, wait a minute, hold on. We have X minus 1, we have X plus 1. We're off. Can we do the same thing we did a second ago? No, because this X is positive what? This X is positive. See, they're the same here. The numbers are different. So if you say, oh, I'm going to try and make this a positive 1, you're going to wind up changing the X to negative, and then they won't match, the X's won't match. So these, although they look like we might be able to do something, we can't. And then same thing with the plus 2 and minus 2, can't do anything there. So our answer is just everything that's left. And you could leave it like this, or you could actually multiply it back out. So this would be correct, or multiplying those together would be correct. Who wants to volunteer the answer here? If I multiply those together, who wants to volunteer? Who can do that mentally?
X squared plus 3x plus 2.
Okay, that's the top multiplied out.
And then x squared minus 3x plus 2.
Good. There we go. See, so you just have to be real with yourself, right? Growing up, my dad had this plaque. He still has it in his room. It's right above his dresser. Every morning he'd go get dressed. And it says on it, your only obligation in life is to be true to yourself. That's always been like this thing I try and live by too. And I tell my students about. If you're sitting here at the beginning of this problem, and I went from this step to this step, and you are being honest with yourself that you cannot do this factoring, you are going to struggle mightily in this class. So you have to be honest with yourself. What's best for you? If you can get from here to here, maybe you need a little scratch work on the side and it takes you a minute or two, great, you're okay. But if this is just, you look at it and you're like, I'll figure it out eventually. You know, like, I hate factoring, I've never been able to factor. You've got to overcome that in order to do well. It's like building a house. You got to be able to know how to use the tools, right? Okay, how am I doing on time? 10 minutes? I want to do one more fraction problem, but this time it'll be an addition problem or subtraction problem. Yeah, let me do a harder one. I like 76. It's called a complex fraction. Complex fraction. Fractions within fractions. There's multiple approaches to this. I want to simplify it. I want to get it as clean as possible. And let me tell you what the final result should be. Calling me? It's all you, James. Oh, it's okay. How many more do we have? This is it. James, the last one. Oh, perfect timing. Okay. So let me tell you what the answer is over here, okay? I'm going to write it down. Just so you can see where it needs to go. That's where this thing should end up when we simplify it. All right? That's what it should turn into. Any ideas?
Can you split them up?
Maybe. It depends on what you mean by split them up. Do you mean... Well, I don't want to speak for you. Do you want to show me? Or you're on camera, just as long as you know you're on camera.
Like that?
Split it into two fractions. So put this over this and this over this. Okay, what do y'all think? Okay, how about this? 3 plus 1 over 2 plus 2. Can you split that into two fractions? What's the answer to this? What's the top? What's the bottom? The answer should be 1, right? Now try splitting it into two fractions. What's 3 halves plus 1 half? 4 halves, which is 2. It's not right. You can't do that. Again, this is me trying to figure out myself. I mean, I knew the rule, but I'm just saying if I'm you, and I'm thinking, can I do that? I give myself a little check. Can I do that? No, it's not going to work in general. So that won't work. Now, if this were multiplication, yes. If you have multiplication between things in fractions, you are allowed to split it into two separate multiplications. Flip the bottom up. Like bring this one and flip it up to this one? Yes, if it wasn't attached to the 2 though. See, the 2 minus is causing all of the headache. If this whole thing were a fraction, we could flip it up. Yes?
Would you find a common denominator?
Between what?
1 and fraction.
So you want to put these two together with a common denominator?
Yeah.
Yes, you can do that. And let's think through why you might want to do that. If I put these two together, it would become a single fraction, wouldn't it? This whole thing would be a single fraction. On the top, I would have a single fraction. On the bottom, if I put those two together, I would have another fraction, wouldn't I? C over D. And now you could do the flipping. But this has to take place first. Good. So let's try that. Common denominator. So anytime we have a common denominator, what we do is we rewrite it. Let me rewrite it. Everything is fractions first. I'm working through this kind of slow because we're still in the first week and I'm trying to take it easy on you. All right? So they're showing some of the detail. I have two fractions here. I want to put them together, so I need a common denominator. What's my common denominator going to be? X plus 1. So what I need to do is put an x plus 1 down here and an x plus 1 on the top, right? And that's basically going to replace, it's going to multiply times 1 and times 1. So I'm going to have an x plus 1 over x plus 1 over there. On the bottom, what am I going to need to introduce? X. So I'm going to multiply this x on top, x on the bottom also. Why is it okay to do that? Why can't I just put that in here? What is this? What's x plus 1 over x plus 1? It's really a 1, right? And multiplying anything by 1 leaves it the same. So here's my new expression. I have x plus 1 over x plus 1 minus x over x plus 1 over what?
2x minus
2x over x. Again, I'm going slow. I know some of you want to put these together already. I'll do that on the next step. So there's my expression now. Now, since these have the same denominator, I can put them together. Almost out of time. So how do I do this? X plus 1 minus x.
well, parentheses, or you just distribute.
I'm distributing this negative to this, right? So that becomes an x plus 1 minus x over the common denominator, over this. And then all that over 2x, be careful here, minus, now there's two ways you can look at it. It's, you distribute right now and you say minus x minus minus plus 1, or you just write minus and then this in parentheses, however you want. But that's one of the big mistakes right here. You have to be real careful on that minus on the two terms here. So I'm just going to distribute it through at one time. It's minus x plus 1 all over x. Are there any questions on that? Why that became the x plus 1? That piece? It's okay? All right, let's just clean that up.
Plus 1 on the top,
Pardon me?
on the numerator side.
What?
Why does it become x plus 1
Here?
on the denominator on top of it? Yeah, right there.
That was what was in the original problem?
So that side doesn't change. Yeah, subtracting the x plus 1 from the x plus 1.
Okay, so are you okay with this line right here?
No, I'm just curious because this is the second step right here.
Yes.
We have an x plus 1.
On the bottom.
Crossing out the x plus 1 in the numerator denominator. What's going on?
Okay, so if I have 3/4 minus 1/4, two fractions have the same denominator. Addition and subtraction of fractions. You leave the 4, right? Subtract the tops 2. Yes? Same thing. So I'm leaving the x plus 1 alone. I'm leaving the x alone.
Okay. Thank you.
No problem. So yeah, I'm gonna cancel some stuff. Those x's are gone. So I have 1 over x plus 1. Then over here I have what, 2x minus x. So x plus 1 over x. And now you flip. So I'm going to get rid of this, multiply by it flipped over. And that's the answer we were looking for. Because if you just multiply straight across, like that, you get an x on top, and then x plus 1 times x plus 1 is the same as x plus 1 squared. But it is not the same as x squared plus 1, right? That's not the same? All right, we are just about out of time. I do have a question for you all. So was that useful at all? What do you all think? Going out there, talking? I know for some of you it's probably like no, but I hope that some of you were able to gain some insight. Everyone understand what the homework is? R2, R4, R7, R8, it's all on here. Remember the calendar. We do have class on Monday. We do have class on Monday. Yes, ma'am. Yeah, in the math the math lab? Is it easy for you to send me an email through Canvas? If you send me an email saying, hey, where are those formula sheets? I will send you a link that you can go download them. Okay? The assessment, yeah, let's get the assessment. Make sure you turn it in up here. Make sure your name is on it. Oh, hold on. Don't do any fancy, everyone, when you turn stuff into me, don't do any fancy corner folding origami stuff. Just make sure your name is on the first page and turn it into me in that order. I will keep it in order, all right? When you do all that fancy folding, it causes problems for me. So just on your first page, lay it on top, and you're good to go. Okay?
Do you need that whole paper too?
I do not.
Okay.
Just the work.
But if we already stapled it, is that okay?
If it's stapled, that's even better. That's the way I prefer it. Oh, sure.
Okay.
Like this, kind of like that? Yeah, that's fine.
Okay, no problem. Because my dad was saying, because it's a mathematical equation, he was like, you shouldn't do that. I'm like, I'll just ask.
Yeah, I guess it would depend on how anal I was about it, but yeah, it's not a big deal for me.